In this journey, free the Fortus, now we have access to push the buttons to print the materials that we need to print that solve the problems our clients are asking us to solve. We are a global partner for Stratasys on the open AM. We're early in the phase, so we're learning, Stratasys is learning, and we're doing it together.
It's exciting for us to be on the cutting edge of this program, pulling the doors off, so to speak.
This is awesome. It's like nothing we've ever done before.
Welcome back to the Free the Fortus podcast, where we share our journey in opening up the Fortus 450 to enable open AM, full unlocked material capabilities. This is our third episode, and it's a great episode. We're talking with 3DX Tech about their materials and opening some of the horizons with materials. But before we get into that, we'll do a quick update from our activities over the last week.
So we're 3 weeks in. First week we had our ABS dial in. Second week we're dial in PEKK. We made it really far with PEKK, and now we're on our week 3. And of course you run into some hurdles. I think one thing that I can underappreciate at time is at DL Labs, we have really high expectations for user interface functionality and our expectation of how a system works. And this week we've run into a little bit of a roadblock with the PEKK, running the PEKK material, and there's some controls and functionality that we're missing. So we met with Stratasys. They're working on solutions to give us the controls that we need in an effort to free the Fortus, make sure that the open AM software can do what it needs to do so we can process these challenging materials and run materials that aren't in the Fortus lineup today. So we're continuing to navigate that, and we're hopeful though. We had great feedback from Stratasys on our discussion, and we're looking to see what they come back with.
Good afternoon. We're here with Matt Howlett, who's the president and founder of 3DX Tech, and 3DX Tech is the leader in material development for fused filament printers, really high-end materials. Glad to have you here, Matt, with us today. Thanks for joining.
Yeah, you bet. Thanks for inviting.
So, Matt, you've got a pretty storied experience, a pretty storied career in polymers. Would you mind sharing a little bit of that with us and what brought you to start 3DX Tech?
Yeah, thanks. And again, thanks for the opportunity. So I've got about 30 years of experience in thermoplastics and specialty additives. And my business partner's probably got about 10 years more than that. And so my background is a lot of the resin plastics companies. I started off with a plastics engineering degree and then moved into these small companies like Monsanto and DSM and Solvay and what have you. And it was really focused mostly on the high performance thermoplastics. And then later into carbon nanotubes, represented one of the larger carbon nanotube companies here in the US. And then after that, the thermoplastics composites side of the business for the world's largest carbon fiber supplier. So if it was thermoplastics related, that was in my wheelhouse. In about 2013, I bought my first 3D printer, and it was kind of cool. I was pretty interested in that. And quite honestly, was underwhelmed by the materials that were available. There were some more interesting materials if you had a OEM system, but even that was pretty limiting. And given my background in thermoplastics, I wanted to see if the market would accept higher performance or more highly modified materials than I could currently find for my own machine. So in 2014, I started the business, and the first offerings, not surprisingly, were kind of centered around my background. So ESD grades, which at the time were pretty minimal. But I used to sell carbon nanotubes into thermoplastic compounds mostly, but into the folks like Seagate, Hitachi, Western Digital, and Terry's, those types of folks that would use the thermoplastics for packaging mostly, but other end uses. And then, of course, my carbon fiber background in thermoplastics for compounds, and then plate and other composites. But the key is how would the market react to having a broader array of these types of materials? And I kind of, quite honestly, I kind of thought that the stuff would be interesting, get us a whole lot of attention, and nobody'd really want it. Who would need, but they'd look at some of the other stuff and say, wow, if they can make that kind of advanced material, this other stuff must be good. And we have, really expanded I've really expanded my understanding of how many people needed that material. So we now have ESD grades ranging from PLA, PETG, ABS, all the way up into polycarbonate, PPS, PEKK, and Altem, PEKK. So every time I turn around, there's another OEM coming to me saying, hey, look, we're doing semicon, wafer fab, and we need something to hold this component. And it's got to be ESD 230C and have chemical resistance to X. And now we kind of have an answer to that question. So what started off in many respects as let's see what happens, it's turned into a core part of our business. Carbon fiber, the same, everything from PLA all the way up to PEKK and PEKK and Altems. And then, of course, our unfilled, which would be the, again, PLA all the way up through PEKK, PEKK, and Altem. So we started that business in 2014 and quickly outstripped the small building that I put it in. And we moved from 1,000 square feet to 6,000 square feet. Now I'm in 68,000 square feet, and we're trying to figure out where we're going to put the next machine. So things on the filament side of the business, we're doing, I think quite well. And the printer, I think we talked about this yesterday. Some of the materials that we have, we're a single supplier in the world. If a company's looking for something that does this, there's really no other option. And that would lead to a lot of interesting conversations with these guys. So a big aerospace customer would come to us and say, hey, we've been using your material, or we want to use material X. What printer do you recommend? And early on, I was pushing them towards several of the more known guys now. It's kind of any port in a storm. It's trying to find somebody that can help me sell more of these materials. And it always turned out to be a trade-off. It was always, one, finger pointing. When things didn't work out, the printer guy would say it was mine, or we could, and they were always, I like to say half measures and partial solutions, and it really wasn't getting the job done. So I knew that we had to take measures into our own hands and come up with our own machine if we wanted to sell more material, especially the kind of materials we're good at. And so I'd say about 3 or 4 years ago, we started developing our HT2 product, which we've just launched in the last 6 or 7 months. And that was essentially our answer to the question of which printer do you recommend to print these materials? And the other thing is kind of like an interesting, we're a very interesting nail supplier in search of a good hammer. And so finally we came out with our own hammer. And we launched that printer in the end of 2021 with our first installation in November. And now we have 15, 18 installations so far this year. So we're right on track for the installation timeline that we wanted. And things are looking up on that machine quite well.
It's really interesting to hear your journey through having client requests come to you and say, well, we need this material and it has to do this and it has to perform this way. It's so often we've experienced those same requests. And in the past, we've been limited because our 450 only runs the same 12 materials as it always has. So it's neat to hear your journey and, opening up the opportunities for running different materials and supporting those clients.
Yeah, it's really neat to, we talked a little bit about this, Matt, but we run your materials, and most of our engineered material production is in PEKK. And it's because of the industries that we serve. And it's a really, as you know, a really tough material to run, even if you have the right hardware, because of the tight processing windows. So that's been what we've been running now for 3 or 4 years. And we've tried all the materials that are available and found that yours is the material that we can rely on as being the most consistent, and it has not let us down. The other part of the equation that we've struggled with is the hardware side. And we've been running an open source machine. Of course, it's not yours, but it is one of the more well-known. And that ended up being our bottleneck is the machine, because the material performed, but the machine, if it didn't need re-engineered, it needed something else because it had subpar components. So it's neat to hear the journey that, as Brian says, the journey that you've taken to develop the materials, but also identify the weaknesses that existed in bringing your own hardware online.
Yeah, and I know the machine you're talking about, and what's interesting about it too is their retail price is about our BOM cost. So, there's an old saying, good, fast, or cheap, pick two. And they picked their two, and we've picked our two. So, we use a high-speed, very solid Yaskawa control system. We're printing Altem 1010, for example, at 300 MMS for some of our composite tool companies, and making beautiful molds for their composite layups. And the chamber gets to 225C, actually 250C, but we don't necessarily need that because 1010 is about the highest temperature material that we can print right now that is commercially available.
Well, we're really pumped. We're the first. Getting back a little bit to the Fortus machine, we're the first, of course, to have an open and unlocked machine, and that's been and you know this, but that's been a challenge in the industry. Is that there's a great piece of hardware, but it's really underutilized with the available materials. Like Brian was saying, there's 12 available. And for us, that's been a major limitation. Of course, we weren't aware of your machine last year. That was ahead of us, or we were ahead of it, rather. But there's been a limitation in not being able to run some of those more advanced materials on a machine like the 450. So we're pretty excited to be running that machine and running it with materials that are not in the typical lot of 12, the dozen of materials. We've actually been running your PEKK on that machine the last couple of weeks, dialing it in, and it's been running pretty well, all things considered. And we're really excited to get some of your other more advanced carbon-filled materials running on that platform, because I think it's going to open the door for applications that we haven't been able to serve in the past, simply because we don't have the hardware bandwidth, so to speak.
Sure. Yeah, and that's, I'm glad they're listening. We've been a division of the company, Triton 3D, that sells consumables into existing Stratasys customers. So if you want an ABS or something with the machine, that's what Triton does. But the feedback that we've gotten from the customers is fine machines, but the materials are way too expensive and there's way too few of them. So of those two gripes, this kind of starts to solve one of them, which is the fewer materials. This will allow, I think, their customers to better utilize the breadth of materials that are out there. There's just 12 materials is 20 years ago's thinking. Cost, it's not really, their solution thus far isn't really effectively addressing any cost-related issues, but it does open up, or has the potential to open up some new materials for folks to be able to choose. I'm glad that you're finding some success with ours. I'm looking forward to more feedback on that.
Having a machine that can process plastic and print plastic is certainly part of the equation. It has to be robust, it has to be repeatable. And the other part of that equation, it's 50-50, it's the materials, and having consistent materials every time we go to print. And, our experience with 3DX Tech materials is that we've relied on that, at least that part of the equation. Even if our machine hasn't been reliable, we know that we can fall back on the materials, and we don't have to diagnose issues there. So we've been, really appreciate your technical input on, process chamber temperatures and your background on managing the printing parameters. That's really important, and we certainly see the output of that, or the result of that, with the materials that we get from 3DX Tech.
That's great. I think you're going to appreciate that. I think you're going to find the carbon fiber reinforced ones too are going to be, much easier to print and offer a whole lot broader array of properties than, say, some of these unfilled ones. The carbon fiber ones, carbon fiber hides a lot of sins, so it, broadens a bit of the processing window, locks in all your dimensions, locks in a lot of the CT, the warp, the shrinkage. And so we've had a lot of success in the carbon fiber PEKK and PEKK. And even our newest grade, our carbon fiber Altem 9085, that's probably one of our fastest growing materials that we've ever launched. And again, it's our aerospace defense guys have really grabbed onto that. But it adds stiffness, strength, and dimensional stability, which is, these materials often lack some of those. So once you do that, I think you're gonna. Let me ask, I guess, did you get the carbon fiber upgrade to the 450?
We do have the ability to run carbon fiber materials with the hardened head with our OpenAM license. Yeah, so we do have the hardened components.
Okay, good, yeah.
So what are you finding for your materials? What are you finding some of the applications to be for? I mean, some of it's obvious, especially with ESD materials, but where are you finding your materials being used in ways that, or in applications that you didn't quite expect as you developed the material?
Yeah, that's across the board, So we've been really lucky with our filaments business. And I probably have, 15,000 customers over the years. So it's a pretty broad array, and you got wonderful guys sitting on a rep wrap machine in their basement, chunking out black PLA parts or whatever, all the way up to things that we know are already in space. We made, for one of the space-related companies, we made a neutron shielding material that was specifically to go up into space. So it's a broad array of things that we're involved in. And when I start to get involved with customers, I'm always surprised, that you're doing what with our material? And sometimes, I don't want to know. I'm like, yeah, I wish you wouldn't do that. but you can't control everything. I think one of the coolest areas that we've been involved in is there's this one aerospace customer who's making a flight. There's some really cool aerospace parts that we're involved in that's really enabling some of the technologies that people are launching right now in our, from our national defense apparatus. And some of our materials are going directly into these applications, and it's actually enabling successful launches of these products. So it's there. We've got a couple of drone companies that have. It's not the kind of drone too. So we're making some parts for camera mounts, but also for structural components or materials for this. And we looked this company up, and I got a hold of them. They're making these huge drones. I mean, huge in my mind, big drones that carry camera arrays, and they'll fly over crops and be able to tell you what area is overwatered, underwatered. This one needs nitrogen, that one's whatever, and probably 20% of that drone and all the attachments, what have you, are made out of our material. And we started talking to these people. It enabled them. They couldn't build molds. They're too small of a company, and it costs too much to build injection molds for what they did. But they can print this stuff out of our materials, and they're flying it over crops in Iowa, telling them, "Well, this crop's fine, but this one needs more of this." And I never anticipated that our material would go into something like that.
Well, that's game-changing from applications in space to drone components enabling applications that otherwise wouldn't exist.
Well, just on that same vein, one of the cooler ones too is there's this 5G company out there that was making these repeaters or something. Again, I bore you to death about plastics, but some of that stuff wasn't me. But it's a small company, and they had probably 17 parts that in this thing they were shipping, I think, through Motorola, but it's a small company, and they were printing it out of our flame retardant ABS because it had to be flame retardant, and ABS was fine. And again, this little company, 17 molds, injection molds for a small company, non-starter, but they can print these parts out of our material, and away they go, and they're in production. And so for these small companies to be able to be enabled to, they probably have 30 employees now. And I don't know how they would have gotten there by trying to find the investment to build all these molds for 1,700 parts. You just can't make money on that kind of volume. But so those are the kind of things too that where you see these guys who are getting into these new applications, and they're using your material instead of traditional manufacturing methods. And not only is it working, but now they've got employees. And those employees have families and houses, and it's kind of cool that company and their products wouldn't exist without the kind of stuff that you and I do.
I couldn't agree more. What does your pipeline look like for material development? How often are you developing new materials? And let's say hypothetically we had a unique application that required a special compound. Is that something that you'd be open to fulfilling? And if so, what would the required volume be for us to do that?
The framework where I started the business kind of tells you where we go. So when I know a bunch about materials, right? But it wasn't there wasn't a completely void out there in 2014. So I made this matrix essentially and put everybody in there. You had the Ninja Flex guys, and the Tallman guys, and the Proto guys. And these guys, you put these guys in this framework that says, okay, this is what they're doing. And I looked for white space that we could do something that I know how to do. And then I figured once we established ourselves as these guys, then it wouldn't be so hard to backward integrate or kind of go after spaces that were previously occupied by somebody else. And so we started off again with the ESDs and a lot of the carbon fibers that were high temp and what have you. And what that's led to is some of these iterative or just an iterative response to customer demand. So we have a high temp application that requires really good friction wear properties. So there's some friction wear materials out there, but nothing that can withstand 250 C continuous use and still retain its friction wear properties, or at least still have some. And so that's an area that we're responding to some customer demand. As you can imagine, it's not going to be a ton of volume, but it's a really interesting strategic customer, and it's an answer that it's something that I can answer with a yes. I know how to do that. And it's, again, the same thing with that neutron shielding application. It came to us and said, hey, can you do this? I said, yeah. And it was obviously not volume, but it was an area in which we could provide value in the background. Yeah, I know how to do that. So if you had a customer that came to you and said, this is cool, but we needed to do this instead, we have those conversations with customers all the time. And that range from, I have a compound, here's a bag of resin, I just need someone to run it for me and ship it back to me. We do that stuff all the time. It's not our favorite thing in the world to do, and a plug and play, but we can do that. Versus, I've got a problem, and that's where my ears perk up. I always love that. I got a problem. I got to do this. And so then we go through the whole process of asking everything about what's the temperature, the chemical, the stresses, the loads, the environmental everything, and we start to try to narrow things down and come up with a material specifically for them. We can do one-offs. They're not amazingly expensive, but we can do one-offs for folks, and we've done that quite often. And it scratches a real specific itch. But if it dovetails with a need on our side of the business, I've always been wanting to do that. I just didn't have an incentive to do it. Then that may be a little bit easier project to get through, because I'm just also going to sell that to everybody else who might want it. So if you came to me and said, hey, I need a blue PEKK, which we've done before for a connectors company, I could do that. But if it's something that a broad array of people might want, then we collaborate maybe at a little lower cost, so that I could then commercialize that to a broader market.
I think that's one of the most compelling things about this conversation that we're having, and the conversation that you and I had yesterday, is because our titles are solutionologists. That's what we're in business for, is solving problems. And we're often faced with those types of questions as well. And in a lot of the scenarios when it comes to material development, that's not what we do. So if it doesn't exist, we have a dead end. And now that we've got the ability to run some of those materials more consistently, and we've got this sort of relationship, there's no doubt that we're going to be reaching out to you, maybe not initially for material development, but for sure leveraging more of your materials to solve problems for our customers, where in the past we've really struggled to have the ability to do so.
Yeah, and I look forward to those conversations. It's always a balance, though. You know how it is. It's always a balance between trying to say yes to everybody and running a robust business that's growing. So you got to say yes enough times that you stay in touch with what's going on, but know enough times so you can hit your growth rate. So, for example, if you had a specialty PEKK you wanted to run, I'm going to be shut down on one of my high temp lines for a day or two, depending on the clean outs and how technically difficult that material is. So I'm not making material for the next day that I probably would have. So you got to pick and choose, the projects. But that's, and I wouldn't say half, but there's at least a dozen products on our website that came from these types of requests. Hey, can you do this? Yeah, I think we can. We made it for them, and now it's for sale. So it scratches both backs, I think.
For sure. We face that all the time, trying to manage the economics of opportunities, and both for us and our customers. And that's exactly what you're talking about. In some cases, it just doesn't work.
So what kind of markets, like from the verticals, are you, for PEKK, where oil and gas or aerospace, or who are you guys mostly focusing that material on?
The three verticals that were most intense with that material is aerospace, DoD, and electronics. All of those, of course, require the same sort of high temperature resistance, and that's mostly where we're using it, is where there's a high temperature requirement.
Yeah, very good. Yeah, one of the things that it's on the roadmap for later this year, but hopefully everything right now, we're in our probably third month of running it. So far, everything looks good. But my old life, we used to run in a lot of materials into LEDs and other applications that would go through lead reflow. So the applications for that, I think, we're working on some pallet applications where you could 3D print materials. So this new materials, 265C capable, ESD, low moisture absorption, strong, stiff, dimensional stability. And that's everything you need right there with respect, not everything, but that's a majority of the things you need for wave reflow solder type applications. And so that's so far been an area that we've had a lot of folks interested in, and POs for printers, but also it runs the gambit. You might be looking at semicon EE specifically for that, but then 3 aerospace companies are doing that internally you didn't know about, and they need it. So when you're out trying to solve a real specific problem, don't be surprised when 30 other customers have that same problem. They're just not vocal about it.
So that's a good point. Do you share some of the materials that you've got in your development pipeline in a way to encourage more customers to contact you, or do you keep that quiet?
Somewhat quiet. Once we, the product development process, there's a lot of dead bodies buried behind the plant. You only talk about, what do they say? Successes has many fathers, and orphan, or whatever, failures and orphan. But yeah, there's a lot of dead bodies buried behind the plant. So we typically wait until we make sure that things are good to go and repeatable and solve a problem before I'll put out a post about it or promote it to our database. And then, we don't operate in a vacuum. We've got, competitors, and they're not dumb. They're smart folks. And so start talking too much. I like to have some space to myself for 6 or 8 months or a year before somebody knocks me off. That'd be kind of nice. So typically don't signal too much. But I don't think that's dissimilar to a lot of folks, but it's the one fun thing that I do like, and I know it's a little bit, probably shouldn't like it too much, but I love it when a competitor buys something I launched 2 years ago. And if you're worried about that, you have no idea what I'm doing now. So that's always a good time.
And that's a great reason to leave some of those things in the quiet and keep them behind closed doors, because you're likely way far ahead of your competitors. I think one of the takeaways that I've got from this is we do come across different opportunities requiring materials that aren't visibly available on the market. We'll definitely be sharing that with you. And maybe if we're lucky, it's something that you're already working on. And if we're not lucky, it's something that you might be interested in working on in the future. But solving problems is something that we're all about, and clearly you are as well. It's really great to hear the technical competence and capacity that your company has to pull this stuff off and do it fairly quickly.
Yeah, thanks. It's the funnest part of the job. is working on those types of materials. Yeah, just appreciate all the business, of course, but all really, I mean, there's probably 2 or 3 guys out there that are doing the kind of work that you're doing in PEKK and PEKK, PEKK specifically. So I don't want to, blow it up too much, but you guys are definitely doing great work in PEKK. So if any of your customers or the people who listen to this, I don't think that they would be surprised that, you can really help solve some of their problems with these type of materials. You guys do a great job.
Well, I appreciate that very much. And I'm looking forward to doing more business with 3DX Tech and maybe in ways that we haven't talked about before today. So thanks for helping us understand your business, your values, and your approach to the market. It's, from my standpoint, unparalleled. So congratulations on your success. It's obviously very well earned.
Great. Appreciate it. I really do.
And thank you for your time today, Matt. It's been a pleasure to connect and hear about what you're doing.
You bet. Thanks, guys. I really appreciate it.